to minima. 0 to maxima to minima. Schrodinger wave equation and Bohr's concept, Bohr's calculation of radius for first orbit of hydrogen atom. The both are in good correlation, good agreement when it is Schrodinger wave equation is solved for single electron system like hydrogen. So clearly I'm saying that the only for s orbitals psi and psi square starts from maxima and approaches to minima. Right. And one more condition I'm saying that psi may be positive, may be negative, and may be 0 also. But psi square only positive and 0. Radial probability always lies between 0 to 1. Radial probability 0 to 1 only. No negative. Nucleus, it is 0, means three-dimensional space which is in the nucleus. If you imagine the three-dimensional space which is very close to nucleus, probability of finding electron is 0. And as you are moving away from the nucleus, the probability of finding electron becomes increasing, chances are becoming maximum, and then approaches to minima again. That is for 1s graph. That is for 1s graph. And now let us go for 2s graph. Let us go for 2s graph. Is that over? 1s, you people understood that? Yes or no? Right, yes, and now I'm going to the second one. That is 2s graph I am giving. See the 2s graph directly 3 I am representing here. So psi versus distance, psi square versus distance, and radial probability versus distance. As actually this is the graph they give, but actual thing is graph appears to be likewise. So this is the graph appearance. So 2s graph appearance I am giving again carefully. So this is the graph for 2s, psi versus distance. So original graph appears to be that, and for visualization, this diagram is given, which means that psi is positive for 1s, and when it is coming from 1s to 2s, 1s to 2s, in between that you cannot find electron. You cannot find electron. As you cannot find electron, some gap is there, and where the probability of finding electron is 0. So psi will become 0 in the point. That is called node. Node means that probability and psi square and psi approaches to 0. So between 1s to 2s. So 1s means psi is positive, but 2s psi is negative. Psi square, if you take 1s psi square is positive and 2s psi square also positive. Radial probability. So first maxima for 1s and again 0, and go to second maxima for 2s. First maxima for 1s and then to second maxima for 2s. At node, radial probability is 0. So this is 2s. Keep in mind that between 1s and 2s, I already told you, between 1s and 2s, I already told you, there will be one spherical node. Spherical node. The spherical node, we know that it is also called as radial node. So number of radial nodes, we know the formula already, n minus L minus 1. N minus L minus 1. As we know that n minus L minus 1, so undoubtedly we will say that. So for 2 years, n value 2, L value 0, n minus 1. 2 minus 1 is 1. So number of radial nodes is 1. The graphs what you have seen for 1s, the same 1s, psi is positive to 0. 2s, positive 0 to negative. Psi square, psi is positive and psi square is positive for 2s also, because only psi square always positive for any orbital. Radial probability starts from 0 at nucleus, goes to first maxima, and again 0 between 1s to 2s. You cannot find electron, and again goes to maxima and approaches to minima. See the number of peaks. Radial probability, if one peak is there, that is 1s. Two peaks are there, 2s. Number of peaks are there. Between peak to peak, there will be node. Peak to peak, there in between that you will have a node. So if two peaks are there, there will be one node. Three peaks are there, two nodes. Four peaks are there, three nodes. Likewise, the understanding. go for 2s over and 1s over similarly 3s. Similarly, so 1s. I already told you psi value is positive for 2s, positive to negative, and for 3s again it becomes positive. Psi square, so positive to 0 and 0 to maxima again approaches to 0 for 2s. Radial probability, the graph. And see, these are the graphs indicating, these are the graphs indicating 1s, 2s and 3s representation. 1s, 2s and 3s representation. So the left side graph is indicating radial probability. Radial probability for the red color peak is 1s. In the back side one, this one. So red color peak is 1s. Exact values also mentioned. For 2s, blue color line, see the peaks. 3s, the green color line, 1s, 2s, 3s. If only hydrogen is taken, 1s. And if you are taking lithium, 1s and 2s. And if you are taking then boron or whatever you take, sodium, 1s, 2s, 3s also we need to consider likewise. So radial probability graph for 1s, 2s and 3s. And this is another graph presenting variation. So first peak to second peak. First peak to second peak elevation. Radial probability graph should be elevated. So 1s, 2s, 3s. Identify 2s maxima, 3s maxima. So 3s maxima is away. As n principal quantum number is more, then automatically distance is far away from the nucleus. Distance is more from the nucleus. Right? So over the two graphs, yes or no? So as you are moving from 1s to 2s to 3s, the peak means probability gradually increasing and distance is increasing both. Probability is increasing
increasing and distance also increasing both. So 1s, 2s, 3s, if you represent it in the same graph, I gave that as a left diagram. And this is left figure is indicating 1s alone, 2s alone. I mean 2s together including 1s. So 1s, 2s, 3s next. So maxima is increasing. At maxima means at the top of the graph. At maxima, at the top of a graph, always slope will be zero. Slope will be zero if you draw the graph for y versus x. At the maxima point, at the maximum point and at minimum point. So dy by dx will be zero where there is a change. The same you can draw for y versus x, and if you are taking this graph also at the minimum point also same we can write dy by dx is equal to 0. Maximum point and minimum point both the cases will be 0. So d by d probability will be 0 at maximum. So mathematical questions they might ask you based on this idea. Okay, next. So keep in mind clearly that point. The point is when you are taking that radial probability versus distance at maxima always. So dp by dr, d by dr of the radial probability will be 0. And in between them, the nodes you will get. For example, if it is 3s, so this is one node and this is another node. So these two are nodes here. And if it is 2s, there is only one node. If there is 2s, there is only one node. Next. Is that over? So if it is done, then I can do one more than 3s. So this is psi versus radius, 3s, psi versus distance, psi square versus distance. And this is 4 pi r square. Already we gave you that. So radial probability versus distance. So this is the first part, second part, and third part for 3s. Yes. psi versus radius, psi square versus radius, and radial probability versus radius. Right. Next, I am going for the next graphs. I think it is done. So, yes, over. Okay, I hope it is done. I'm going on to the next one. That is 3s orbitals. Probability graph we give. So psi versus radius distance graph, psi square versus distance graph, and radial probability versus distance graph. Next, 3D graphs are similar. Similar graphs are similar means I said the representations are similar, but distance is variable. R max for 2p and R max for 3p or 3D are not same, but their notations and the representations are same. I already told S orbital starts for maxima to 0. That is for S orbital. But for P orbital, psi, psi square, psi and psi square graphs always starts from 0, including radial probability. So psi versus radius, psi square versus radius, radial probability versus radius, all are going to start from the nucleus only and from 0 only. So 2p or 3D the graph, 2p or 3D the graph, 2p or 3D the graph. So S orbitals and P orbitals, you need to differentiate only one word. S orbital starts for, so from maxima to minima at nucleus also, but for P orbitals, psi, psi square, radial probability versus distance, all the graphs starts from 0 and goes to maxima and then to minima. Maxima to minima. Okay. So 2P and 3D graphs are same. 3P and 4D graphs are same. 2P, 3D, or we can write as 4F also. 2P, 3D, 4F. 3P, 4D, and 5F are similar. The graphs are similar. So if you know one and remaining all you can predict. Only s orbitals are different, but p and d orbitals and f orbitals graphs are all similar. Similarity is there. Similarity is there, graphs. Yes, 2p, 3d, 4f graph over. Yes or no? You should practice them. You should practice them from my end. There is nothing to do. Only the simple graphs representation I can give you. So for 2p, 3d, 4f, the graph starts from 0 to maximum and then to minima. And you people might be misbelieving that, misunderstanding that. So, sir, as it is approaching to 0, can we take this as a node? No, you cannot. You cannot. It approaches to 0, I said, and it is not exactly 0, I say. Okay? So that is not node, don't consider. So node, when you want to take the node, it is if it is in between the two graphs. If it is in between the two peaks, you consider as a node. Two peaks, you consider that as a node. Understood? So these are the nodal points. But for a single peak, do not represent a node. That is not possible. Because P starts from second, D starts from third orbit, F starts from fourth orbit. So beginning of the respective subshell or orbital, 2p, 3d, 4f, the graphs are similar. So next graph is for the remaining, that is, 3p, 4d, or 5f. The graphs are similar. See, psi may be positive or may be negative via 0. Psi square always positive, but radial probability lies between 0 to 1. Distance is increasing. So between two peaks, you will have one node. So 3p, 4d, 5f means 2p to 3p, there is one node. 3d to 4d, there is one node. 4f to 5f, there is one node. Likewise, we need to understand them. Yes, Medhan, stop.
So can we take these all? You told that we can't consider them as nodes, no, sir. So can we take them parallel to the x-axis, means like
Yeah,
that only, sir?
approaching to 0, we can say, but they never be intersecting there almost.
Yes, sir. Never touching x-axis, but parallel to them. Yes, sir. Thank you.
Okay, so these are the graphs for 2p, 3d, 4f, and 3p, 4d, 5f. The graphs. And now I'm giving the clear representation. I'm giving the clear representation. See, I already told that 3p and 4d graphs are similar. I told 3p and 4d graphs are similar. They are similar, I said, but I didn't say R maximums are same. Values are not same. The appearance, what they look like, first one peak, then the second peak. So minima to maxima, the inclination you can expect among the peaks. Between two peaks, there will be a radial node. So everything is similar, but not the values. Similar, but not same. Okay. So 3P and 4D, the next graph, 3P and 4D are maxima. So 4D, fourth orbit, 3D, third orbit, fourth orbit and third orbit, which is relatively far away from nucleus. So fourth orbit is far away from nucleus. So 4D is lying far away from nucleus and 3P is trying close to nucleus relatively. So Rmax is always more for 4D because fourth orbit relatively is far away from the nucleus. That's the meaning. 3P is lying close to nucleus. 4D is lying far away from nucleus. And if you try to identify 4S or NS, NP, ND, NS, NP, ND. Right. For example, if you take fourth orbit, we have 4S, we have 4P, we have 4D, and we have 4F. But 4S comes after 1S, 2S, 3S, then 4S. 4P comes after 2P, 3P. 4D comes after 3D. 4F comes after nothing because that is the starting number 4F. And if you are taking the same NS, NP, ND, NF, then which is lying far away? Principal quantum number same, NS, NP, ND, NF. When you take the same, in the particular case, NS always lying far away. NS lying always far away. For different n values, higher n value orbital lies far away. That is clear. And for the same n value, S lies far away from P, then D, then F. So R max is more for S, then P, then D, then F. Okay. So if you are taking the 3S, 3P, 3D, 3S, 3p, 3d. Next point I'm giving it 3s, 3p, 3d. I will give you that. And before that, till now, whatever we explained, the generalizations I give. So for s orbital, and then 2p or 3d or 4f similarly. For 2s, so first becomes up and to negative, positive to negative. So 3p, 4d, 5f. Then chi-square graphs, psi versus distance graphs and chi-square versus distance graphs. Okay. So 1s, 2s, 3s, and so on. And similarly for 2p, 3p, 4p, and so on, we can mention them. Right? Next. So I already told you this is a simple point picture representing simple picture representing NS, NP, ND, and R maxima comparisons. So first one is for 3S, the next one is for 3P, and the next one is for 3D. Next one is for 3D.
Maths class.
Sir, in your class, CEO
Sometimes it
entered,
comes.
sir, last time.
Got it, brilliant.
CEO.
Right? So this is a simple graph. R maximum gradually decreasing for NS. So again gone. Very good. So it is playing games with us. So 1 second, it's getting open. right? So this is NS, NP, ND. Keep in mind that, so this is R maximum, but commonly we say that, always NS is always closer to nucleus than NP, then ND. This is only R maximum distances comparison. So in the orbital wave function, if R is substituted as 0, R is substituted as 0, then if you are getting psi is 0, that is representing that relative closeness of the orbital. And particularly penetration power, I am giving the word penetration power. Penetration power means relative closeness of orbital electrons towards nucleus. So S electrons being spherically symmetrical, they always try to stay close to nucleus. Then p orbital electrons, then d orbital electrons, then f orbital electrons. Penetration power is more for S, then p, then d, then f. Relative closeness. Electrons trying to stay close to the nucleus. Right. So here I'm giving two questions here, just only for practice. Which kind of questions they will ask you over this graph? So only for practice, I'm giving these two. So take the screenshots and practice them. Take the screenshots and practice them. So question 1 and question 2. So the respective graph is representing to which one? So right now you need to say answer. Just I'm giving for work, practice work. You people can say answer in tomorrow class, no problem. Just let us finish the discussion first. Next. Okay, so this is only for working I give, and then I'm giving you the next point. This I'm going for radial and angular, that psi can be represented as a product of two functions. One is radial part, other one is angular part. One is radial part and another one is angular part. Radial part, angular part. So that representation I'm giving. See carefully. Psi represented as So psi n l m. We represent it as radial part of the wave and angular part of the wave. So radial part of the wave function and angular part of the wave function, the two parts I am giving here. So radial part, and keep in mind psi has different notations. You know already psi is characterized by a set of ml, three values, three quantum numbers we use for representing psi. Three quantum numbers we use for representing the psi. 3, 2, 0. N is equal to 3, L is equal to 2, ML is equal to 0. Okay, N, L, ML. Now, so to represent this radial part of the wave and angular part of the wave, and before that, we should represent that psi n, L, ML values. 320 representing 3D square, 300 representing 3s, 311 if you take it may be a 3px or 3py. It may be a 3px or maybe a 3py. We need to say that. Okay. Right, for 3 years. Now, I'm going to give you some functions, and these functions first, you just note down them, and then I will explain them. Because the material also the same data was given, but they are having different values, little bit variation is there. And for every orbital representation, see, you no need to by heart them. I will give you logic. You no need to by heart them. I will give you logic how to identify. So just to copy these two. Just copy these two enough. No need of by hearting them. No need to by heart them anything. right? Over. So copying over. You no need to by heart them. Strictly I'm saying no need to by heart them, just to copy them. And there is a trend and there is a technique how to solve such kind of questions if they ask you. And in exam, they don't ask you the value. What is, just write the expression for 2px. They don't ask you. They will give you and you need to identify which is 2px. Understand? So radial part and angular part of the wave. Clearly copy them both. So X stands for angular part, R stands for radial part. So radial part of 1s, radial part of 2s, where sigma, we have in the radial part sigma. Sigma is 2z r by n a naught, where a naught is Bohr's radius. 2z r by n a naught. Right. Samik, copied?
No, sir. Can you scroll down? One formula was there.
Yes, it is there.
Yes, sir. Yes.
Right. So I will give you that idea how to use this, and how to get them.
Sir, what is theta and what is pi, sir?
Excellent, mister. You have asked a good question. It's a long story, man. Almost 3 days back or 4 days back, I told you. And the thing is, wave function psi, if you are taking that polar coordinates r theta pi I gave you.
Yes, sir.
So to give clarity over this point, I am giving clearly, see that if you are trying to write wave function of 1s, wave function of 1s, wave function of 1s we mention as it is the product of radial part and angular part. What is radial part of 1s? 2 into z by a naught power 3 by 2 into e power minus sigma by 2. And what is angular part? Angular part, angle independent for s orbitals. For s orbitals, there is no angular part, only a constant we have. So cos theta, sin theta, cos pi, sin pi, it is independent. S orbitals are spherically symmetrical. As they are spherically symmetrical, they are non-directional. That's a point we gave you. As they are non-directional, they are independent on the angular part independent. So similarly write psi 2s. Similarly write psi 2s. So this part is becoming now as a radial part, and this part is angular part again. This is radial part and angular part. For 3s, similarly write yourself radial part and angular part. You only write based on the table. I'm giving how to frame the wave function based on the table of content. Based on the table of content, how to frame the wave function. Psi 1s, how do you write? Radial part and angular part product. Psi 2s, radial and angular product. Psi 3s, radial and angular product. Likewise. Just mention them. I will give you a technique. Kind of questions they will ask you, and how do we solve them based on our ideas. So do you understand now how do you write wave function, angular part and radial part together? So left side table is radial part separately, angular part separately given. If we combine both, how do we write? I give. So writing for 1s, writing for 2s, writing for 3s over. Writing for 1s, writing for 2s, and writing for 3s over. Okay. Saying no. right? So writing for 1s, 2s, 3s over. Now, the clear meaning I'm saying, just pause it. See for first orbit, 1s. Is there any sigma term in the expression? No, only e powers are there, but normally we have no expression. And for 2s, we have 2 minus sigma. We have 2 minus sigma. So sigma power 1, order of sigma is 1. In 1s, order of sigma is 0. There is no sigma term. So psi 2s is a sigma power 1. Psi 3s is a sigma square we have. Sigma square power to quadratic equation we have. We know for 3s orbital, for 3s, there will be two radial nodes between 1s to 2s and 2s to 3s. There will be two radial nodes. At node, what is the condition? Psi square is 0. Psi will be 0. Means the entire expression you need to equate to 0. So 1 by 9 root 3 z by a naught into O whole power 3 by 2 will not be 0 because those are constants. E power minus sigma by 2 never be 0. 1 by 4 pi power 1 by 2 never be 0. Then which will be 0? 6 minus 6 sigma plus sigma square. So total, if you are taking, a into b is equal to 0, means a may be 0 or b may be 0. If a into b is equal to 0, which means that a may be 0 or b may be 0, like the same. At node, psi square is 0, that means psi should be equal to 0. So number of radial nodes for 3s we write as 3 minus 0 minus 1, that is 2 we will get. Right, there are two radial nodes. So at what distances we have radial nodes for 3s? For 3s, at what distances we have radial nodes? That also we can calculate. That is a speciality of these ideas. Listen up carefully. S orbitals. So cos theta, sin theta, cos pi, sin pi is not there. So angular part independent. Point number 1. Point number 1. All S orbitals are angle independent. Angle independent. So they are independent over the angular function. So sin theta, cos theta, independent on theta and pi. Directly mentioned that all S orbitals are independent on theta and pi, and depends only on the radial part. Depends only on the radial part. Just write the two lines. For S orbitals, for NS orbital, whatever you say that for NS orbital, you need to say that. You need to say that NS orbital wave function is independent on theta and pi. Independent on theta and pi, but dependent on radial part. Dependent on radial part. Psi 1s is proportional to sigma power 0. Mention that. Psi 1s is proportional to sigma power 0. Psi 2s is proportional to sigma power 1. Psi 3s is proportional to sigma power 2 maximum values. So order of sigma value I am writing, and from this conclusion, what we can say that psi ns, even for n, whether it is not only for s, it is for n, maybe ns, np, nd, nf, we can use all. So psi of nth orbit is directly proportional to sigma power n minus 1. Sigma power n minus 1. For understanding, in the above cases, we got psi 1s is proportional to sigma power 0. So psi 2s is proportional to sigma power 1. Psi 3s is proportional to sigma power 2. Maximum factor. orbital wave function psi of any wave function n means principal quantum number n directly proportional to sigma power n minus 1 r power n minus 1 because sigma is equal to 2z r by a naught. Now, this is the story. So we can assume that psi n is proportional to sigma power n minus 1, psi n is proportional to r power n minus 1, where n is the orbit number. So first examine the expression. By seeing the expression, you decide that belong to which principal orbit, which n. In the expression, if there is one sigma term, only sigma power 1 means it belongs to second orbit. If it is sigma squared, it belongs to third orbit. If it is sigma cube, it belongs to fourth orbit. If no sigma is there, it belongs to first orbit. First decide the radial part, n principal quantum number we decide. Okay, psi of n is proportional to sigma power n minus 1. So this is the most important conclusion we will take. Most important conclusion we will take. Psi n is proportional to r power n minus 1. All s orbitals do not depend on theta and pi, but p orbitals depends on theta and pi. See the stable way again. X, py, pz. So in the function, if you have only cos theta, that will be pz. Identify first principal quantum number. For example, if you got second orbit based on sigma terms, second orbit dependent. If it is cos theta dependent, pj, I mean it will be 2 pj. If it is sin theta sin pi dependent, that will be py orbital. If it is sin theta cos pi dependent, px orbital. Okay, so cos theta or sin theta sin pi or sin theta cos pi. If they are dependent over the angles, angle dependent means always, angle dependent means always directional. They are directional orbitals, means they should be a p or d. There should be either p orbitals or d orbitals. So px, py, pz, angle dependent. And if it depends on cos square theta, that is dz square, depends on sin theta, cos pi. So this is the need of remembering. You no need to remember the formula. Whatever use the expressions, you don't remember. No need. Whether it is angle independent or angle dependent, identify. If it is angle independent, clearly it's orbitals. And identify sigma power. So based on that, identify the orbit number. So ns, clear. Okay, and from the same picture we can get n value and then theta dependent or not. If it is theta dependent, so dz cos theta dependent, sin theta sin pi, sin theta cos pi. If only theta is there, that is z. Only theta is there, that is z. Only cos theta, pz. Cos square theta, dz square. Cos square theta, dz square. So that is way of identifying them. That is the simple way of identifying the orbitals. You no need to remember any equation. They will ask you question and they will ask you this representation belong to which orbital exactly. So I'm giving a simple question here. I'm giving a simple question here. So find the answer to the question if you understood the above concept what I gave. I gave a question and you people try on your own what will be the answer to the question. If you understood the above logics. So anyone? So just express the final answer in terms of R and A naught. In terms of A not express that. Because R stands for distance. At what distance it is? What distance it is? Let us see how many people can say the answer to this question. Yes, I will explain as usual. There is no problem. So definitely it's a different question because till now you didn't get exposed to this kind of models. So I'm trying to present every concept we are having some mathematical skills. For this Schrodinger wave equation, the mathematical skills we need in different direction. We need in different direction.